So today we're going to go over phase changes, or more specifically the enthalpy of phase changes. Okay, so first we have the delta H of fusion, which is the change in heat that occurs during fusion. It is the heat absorbed by 1 mole of solid when it melts to give liquid at a constant temperature and pressure. Next we have the delta heat of vaporization, or delta H of vaporization, which is the change in heat during vaporization. It is the heat absorbed when 1 mole of liquid is changed to 1 mole of vapor at a constant temperature and constant pressure. Lastly, we have the delta H of sublimation, which again, change in heat that occurs during sublimation. It is the heat absorbed by 1 mole of solid when it sublimes to give 1 mole of vapor at a constant temperature and constant pressure. However, for this experiment, we're actually not going to be using delta H sublimation, just need fusion and vaporization. So keep that in mind. Now, the example we're going to do today is water has a heat of vaporization of 43.9 kilojoules per mole. Its heat of fusion is 6.02 kilojoules per mole. And then its specific heat is listed in the chart that I'm going to write for you right after this. So the question that we're trying to answer is, how much heat is required to warm 105 grams of water, or H2O, from negative 22.5 degrees Celsius to 75.0 degrees Celsius. So make note of that. That's what you're trying to find out. Okay, so what we want to do first is write our specific heats in the little chart that I said I was going to give you. So specific heat for ice is 2.09 joules per grams degrees Celsius. Water is 4.18 joules per grams degrees Celsius, and steam is 2.09 joules per grams degrees Celsius. So now we want to write our formulas for Q1, 2, and 3. For Q1, it's ms of s delta T. Q2 is N in moles times delta H fusion, and then Q3 is ms of L delta T. So for Q1, we're trying to find solid, and Q3 is liquid. That's why there's an S in the L. Okay, so you want to do your little phase diagram type thing. It helps if you visualize it. So you want to do temperature in degrees Celsius by the heat at it. So you put your negative 22.5 degrees, your 0 degrees, and your 75.0 degrees, so you know where to mark where the changes occur. So you put the points on, and you draw your lines. Obviously, this is just to help you visualize things. So Q1, Q2, and Q3 on it. And then for Q1, it is negative 22.5 degrees Celsius. During Q2, it's 0 degrees Celsius. And then during Q3, it is 75.0 degrees Celsius. Okay, so now what we want to do is write down, what we're looking for, Q1, Q2, and Q3. So for Q1, it's ms of s delta T, which is 105 grams, mass given, times the specific heat of ice. And then you multiply that by the change in heat that occurs during that. So you're getting 4,938 joules, which is 4.938 kilojoules. You want to mark your sig figs, but keep all of the numbers. So for Q2, it is N in moles times the delta heat of fusion, which is equal to 105 grams times 1 mole of H2O over approximately 18.015 grams, because you want to get the molar, or the moles, not grams for this. And then you multiply that by 6.02 kilojoules over mole, which is the specific heat of, or is the heat of fusion, I'm sorry. And then you get 35.09 kilojoules. So for Q3, you do ms of L times delta T, which is 105 grams times 4.18 joules over grams degrees Celsius times the change in temperature that occurs and you get 32,918 joules, which converts to 32.918 kilojoules. The 0 degrees Celsius, we're not going to use that for sig figs because it's an exact number. So we're going to do just write down what we got into our, like, on the side, so that we have that and we can erase, everything, whatever we need. Now you want to find the Q total. Q total would be it's Q1 plus Q2 plus Q3. Pretty simple, right? So what you want to do for Q1 is 4.938. Remember where your sig figs are, and then you add 4.938 kilojoules plus 35.09 kilojoules plus 32.918 kilojoules, and you get 72.9 kilojoules total. So basically, 72.9 kilojoules are required to heat 105 grams of H2O from negative 22.5 degrees Celsius to 75.0 degrees Celsius. And that is how you find the enthalpy during phase change.